Hey everybody, Sesto here. Welcome back to the MetaTrader 5 Quant Server with Python tutorial series. This is video number 4. So far in this tutorial series, we have built a Flask API and a Django server that interacts with our MT5 instance, deployed on Linux server environment using Docker. We have also implemented a trading algorithm infrastructure that fetches data from our MT5 instance and executes trades based on predefined strategies. By the end of this video, we'll enhance our system by implementing a comprehensive monitoring system using Grafana, Prometheus, and Loki. You'll find the source code for this video in the Chapter 4 branch of the repository. The link to the repo is provided in the description of this video. First, clone the Chapter 4 branch from the repository. Open your terminal and execute git clone b chapter 4. Single branch and paste the URL of the repo. Let's open the cloned repo using an IDE. I'm using VS Code. The main changes to this project is the addition of the monitoring folder and the changes to the docker-compose.yaml file. Let's go through the changes in our docker-compose.yaml file. We've added several new services for our monitoring stack. Grafana is our main dashboard interface. It is pre-configured with custom dashboards and accessible through a secure domain. It is connected to Prometheus and Loki data sources. Prometheus collects metrics from our services and stores time series data. It also handles alerting rules and provides query capabilities for Grafana. Loki and promtail store and index our logs and enable powerful log querying and visualization. Node Exporter collects system-level metrics such as CPU, memory, disk, and network statistics, and provides detailed host metrics. cAdvisor collects container metrics such as resource usage and performance characteristics, and provides container health monitoring. alertmanager handles alert notifications and routes alerts to appropriate channels. It also manages alert grouping and silencing. Let's look at some key configuration files. Prometheus configuration is located at monitoring/config/prometheus/prometheus-yaml and defines scrape targets, sets up alerting rules, and configures recording rules for complex metrics. Grafana dashboards are located at monitoring/dashboards and include node metrics, container metrics, and log search. Alert manager configuration is located at monitoring/configs/alertmanager and defines alert routing configuration, notification templates, and grouping rules. Loki configuration is located at monitoring/configs/Loki and defines log retention policies, index configuration, and query limits. Now, let's deploy our monitoring stack. SSH into your server. I'm on PC, so I'm using PuTTY to SSH into my VPS. If you are on Mac or Linux, you can use the terminal to SSH into your server. We'll clone the Chapter 4 branch from the repository. We then type in cp nv.example.nv, then type in nano.env. The main new environment variable since the last video is Grafana _domain, the URL of your Grafana dashboard domain. Save and exit nano. There are 2 more steps which are the same as previous videos. We have to create the Docker network using Docker network. Create traffic public. And we have to provide the hashed password for the traffic dashboard using this command, which is provided in the README in the repo. Now let's start our services. docker-compose.yaml. After deployment, access your MetaTrader 5 dashboard and log in to your broker account. Then access your Grafana dashboard at the domain you specified. You'll see several pre-configured dashboards. First dashboard we're going to go through together is Container Log Search. This dashboard is used to search and filter logs from all the containers in our system. It is connected to Loki, which is our logging service. We can search for logs by entering a query in the search bar. We can also filter the logs by time range, container name, log level, etc. We can see the messages sent from Celery Beat, which are sent periodically to the Celery worker through the Redis message broker. Next dashboard we're going to take a look at is Container Metrics. This dashboard is used to monitor the resource usage and performance characteristics of our containers. It shows us the CPU, memory, disk, and network usage of our containers. We can filter the data by container name, time range, etc. Last dashboard we're going to take a look at is Node Metrics. This dashboard is used to monitor the resource usage and performance characteristics of our host machine. It shows us the CPU, memory, disk, and network usage of our host machine. We can filter the data by time range, etc. That's it for Chapter 4. We now have a robust monitoring system that gives us real-time visibility into our trading infrastructure, early warning system for potential issues, historical performance data, centralized logging, automated alerting. In the next chapter, we'll build a custom front-end dashboard using Next.js and Tailwind CSS to provide a user-friendly interface for managing our trading strategies. Thank you for following along. If you found this helpful, please give it a thumbs up and subscribe to stay updated with the latest tutorials. See you in the next chapter.